Hey guys, I wanted to talk a little bit with you about this ranked choice voting assignment. Ranked choice voting's been in the news a little more lately, and I thought it might be an interesting exercise to try and um, write some code to try out some, basically simulate some ranked choice voting scenarios. So that's what this is based off of. I also came across a couple funny memes about Gollum for president, and I couldn't resist incorporating that into an assignment. So I have the files for this downloaded. I'm going to open up a Jupyter notebook and navigate to where I have that saved. Oh, no, those aren't the right spots. Pretty sure that is in my downloads folder. And there it is, ranked choice voting. And I'm going to open up the Jupyter notebook. You could easily do this in a .py file, but I wrote it in a notebook and gave a template here to complete the steps of the assignment in. So I tried a little bit of a different format. I tried kind of describing what I was doing in each cell, and then I actually haven't just showed the code in case you want to try and write some of this yourself and give that a try. Sometimes it's nice to try something out without having seen an example first. You may think of ways to do things that I didn't think of. And it's also just helpful to work on a problem a little bit yourself. So I might encourage you to give that a try, especially with some of these simpler areas where it's a little more straightforward. Some of my functions, which I came up with, that may be a little harder to replicate. But anyway, you can see, so here I'm creating a list of candidates, and there's a drop down with a code box, and you can see what I have there. And I'm not going to recreate everything on the screen, and GitHub provides you with a nice little copy button. So I'm going to paste the code into these places and go ahead and run it. And you'll see there's no output on that because it's just creating a list with that list of names. So that's supposed to be a list of candidates. And of course, this is from Middle Earth, so we have our some of our best ones. Obviously, it's not comprehensive. You can make up your own. We're going to simulate some ballots, and I used a list to do this and some random sampling, and you can read through the code and look at what I did. And it might be useful for you to, so you'll see here, I've got the random package. Normally, it's good practice to import all of your modules at the beginning, but since this is an exercise, I'm just importing them as I am using them in my code. I think it's a little easier to understand that way for learning purposes. And you might try printing out, if something is created here and we run it, what you can see here is, and there may be better ways to do this, but I made an empty list called ballots, and I want to simulate 20 ballots. And this is creating a for loop, which is starting at index 0 and going up to however many ballots that we want to simulate. And then I'm generating a random number. And this is something where you could make this something that's fixed by commenting that out and picking a number. But I wanted to try out a little bit, what happens when some people vote for all the candidates, they put them in rank order that they would like them, or what would happen if there was a set number. So I created it to randomly pick how many candidates somebody submitted ranks for. And so it can go from a single candidate up to however many are in our candidates list. Because I could imagine that not everybody would vote for everyone. So I thought it was an interesting thing to look at. So you'll see here when I used the random, this person picked 3, this person picked 1, 2, 3, 4, 5, this person picked 1. So it changes that. But if I change that code to a fixed number and run it, you'll see that everybody selects their top 3 candidates. So I thought this was a fun thing to play around with a little bit, to see what happens with the outcome of the elections as those things change. One thing that I noticed from kind of playing with this code a little bit, because I was trying to understand ranked choice voting and how it works a little better, is when you have a low number of ballots. In this case, I'm only doing 20. I want to keep this as an example that I can actually look at and understand a little bit. And a higher number of candidates, here we've got, I didn't even count them, but there's a good number listed there, that you're going to get errors later on in the process when you're trying to eliminate. The more ballots that you have and the lower number of candidates, the easier it is to for the algorithm to settle on a solution. So that is something interesting to look at and play with a little bit. You might run through this a few times and change some of the settings and see what happens. So in this next one, I'm making some functions here. So I kind of describe the function and we'll go through and build them as we go. So there is a function to count the ballots, and this will kind of walk you through what this is doing. This is accepting a list of ballots, and we're going to put the ballots into a dictionary called results. So I make the dictionary, and then I go through the ballots, and if there isn't a ballot there, this line was needed because sometimes if somebody only votes for one candidate and that candidate gets eliminated, they don't have any more items in their list. So you have to write something to continue on if there's nothing there to count. This was actually useful. It kind of shows if you only vote for one candidate in ranked choice voting, you've lost a voice as soon as that candidate, if that candidate gets eliminated, you're no longer voting, you're no longer contributing. So it's probably not in your best interest to only select a single candidate. If the first candidate in the list, and this I ran across while I was doing some Googling, this kind of relies on the fact that these lists have this order to them. And so really for each round, we only need to count the first person in the list. And that's part of how ranked choice voting works is you look at the first round and make the counts, and the lowest person with the lowest votes gets eliminated. And then you look at the next set of numbers that are left and recount, and the votes that went to the person who was eliminated will go to their next choice down, and you kind of get a revised counts, and it keeps going until somebody reaches an actual majority. So that's what this is doing. If that person is not found in the dictionary, it's going to add them with a count of 1. And then if they are in the dictionary, then it's going to just increase their count by 1. So that's what that function is doing. I wanted to kind of see how things happen, so I made a little text report, which we could call at each round to print out a summary. So I was looking at, what was the lowest count and who received that count. And you'll see when we have the situation of a lot of candidates and not very many ballots, sometimes there's several individuals that have that. So we're working with some lists there. I wanted to see what the high count was and who was in the lead with the high count. And again, sometimes you're going to see some ties if you print that out. And then I made this function called keylist, and I basically wanted to get a list of you can pass a dictionary with results and a number, and in this case I'm either interested in the low count or the high count, and generating a list of the names that had that count. So that's what this is used for. So we'll go paste that in our code, and I'll run all these as soon as I get these different code blocks put into our Jupyter Notebook. So we made a function to drop the lowest, the people on the list with the lowest counts. Then we're going to drop them from everybody's ballots. That's what that's going to do. And then we're going to get some summary information about this simulated election. And so we're going to get a list of who the candidates are, how many total ballots there are, and we're going to calculate how many we need for a majority. So if the number of ballots is even, then we need to get 50% of that number of ballots and add 1. And if the number of ballots is odd, then we just simply need to get 50% and round up. And that's what this ceiling function does out of the math module. Is it just the math package? It just adds, it just rounds up if it's not evenly divisible, and then that will give us the majority needed to win. And finally, there's a code block to use all of these functions, and it just uses a while loop to go through rounds of counting and run through it again if no majority is reached. So now that I've got all my code blocks, you can see the ones that I've run, and then the ones that I haven't, they have no count there. So I'm going to go through and run them so that these functions are in memory for when we hit the last cell there. And there's no output because it's just defining functions. So we see here's our list of candidates, and you can play with that, on your own. You can make that longer or shorter to try things out a little bit. And of course, we set this number, so it's not surprising, and we need 11 to win. That's a majority. And we'll run this last block and see what happens. So I kind of wanted to follow it through, so you'll see we have some results from the first round. Here is our list of candidates and how many votes each one received. We see several had only 1 vote, so that's the list that we're going to remove. Somebody had 4 votes, and that's who's currently leading. So then after we remove these people with the lowest number of votes. Here are revised counts, and you'll see we still have several ties in there, and we have several with 3, which is actually everybody with 3, and this is one of the problems of having a lot of candidates and not many votes, is you get a lot of ties. And then a high count of Gimli, but he's still not, doesn't have a full majority. So if they eliminate all of those, now we can see that somebody new has come in there because they were some farther down on somebody's list, and we still don't have a majority yet. And when we do this, we can see that we actually he never reached a majority, and this is one of the problems of having a lot of candidates. And you can play with this a little bit. If I go through and try this out again, I'm going to go switch this. And part of that was from only having people rank 3 candidates, but having quite a long candidate list. So I'm going to change this so that we get some ranks that are longer than just 3 members. And we'll go through and run this again. And I'm just going to go up to cell and run all. And we can see these results. Again, if you look through it and go through, there's several rounds. And this time, Gollum got to 15 votes. So in this simulation, Gollum became the new president of Middle-earth. But I thought this was a fun exercise. Helped me understand some of the ranked choice voting algorithms, especially, and there's different ways that some of these things are done. So it's good to understand what rules a certain election is following and how they are eliminating. And this is, one example where it goes round by round and looks only at the top choice and does not make any considerations on, who's in second or third place. And there are different types of algorithms that could possibly be used there to look at overall votes and count those a little bit differently, taking into account, first, second, third, however many choices, and where people fell in those, which might give some slightly different results. So these algorithms are pretty important because these are being used in elections for offices. So anyway, that's a little bit of review of this, the code in this assignment and the purpose, and I hope it's an interesting assignment for you. And this is an example of trying to come up with some functions which can be reused, and the one that got used the most here is this this key list. I used this for getting lists of candidates who had the high counts and the low counts, and I didn't have to rewrite the code because I just had it take a dictionary and a number, and I just used it in my code where where it worked. And actually this got referenced in this report. You'll see I was using this key list to get my high counts, my list for my high counts and my low counts, and it also gets used in the while loop. So that saved me a bit of writing by formatting that way. And you'll see here when we're looking for a winner, if we have somebody that gets the majority, then we get the name of that person. So anyway, I hope you enjoyed this and it's been instructive, and I hope you have a good day.